This is 6.1 part 2. So I was talking about negative exponents. So if I want to look at my calculator for a second, and I wanted to see how I simplify 5 to the negative first, I can just type it into my calculator. 5 raised to the negative first. And my calculator will show me the answer is 1/5. Can you see that? 5 to the negative fifth is 5 to the negative first is 1/5. So basically that is, I could write any whole number over 1. Well, if I want to make that exponent a positive, I'm going to drop it over the line. So it comes down from the numerator to the denominator. My negative sign drops, so 5 to the first is just 5. Now you can't ever leave this blank up here on the top, so the only thing you can put up there is a 1. And so 5 to the first power is just 5. So this simplified as 1/5. Letter B, I could write any whole number or variable over 1. That's a negative exponent. I want to simplify it so that I only have positive exponents. That's what the directions say. So I'm going to go over that line and change the sign. I'm going to drop x to the denominator. My negative sign goes away. I can't have the top blank. So this is now simplified. Letter C, I'm going to show you 2 different ways to do this. The first one is using the rule. If you have 2 numbers that have the same base and you multiply them, the rule is to add the 2 numbers. So my first exponent is -9. My second one is 7. These have the same base. They're being multiplied. So the rule says to add. So -9 plus 7 is -2. To make that a positive exponent, I drop this that's in the numerator down to the denominator. X to the second, drop that negative sign. I can't have the top blank, so I have to write a 1 on top. Now the other way I want to show you is if I want to look at each number individually. Well, if this is right now in the numerator and I want to drop it to the denominator to make it a positive 9, and I'm multiplying that times 7. Well, 7 is up here on the top, so it's going to stay on the top. And so basically, since I had to drop this to the bottom, it looks like a division problem. And division says the rule is if you divide 2 numbers that have the same base, you subtract their exponents. Well, isn't 7 minus 9 -2? So if I wrote that out, I would literally have 9 x's on the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'd have 7 on the top. 1, 2, 3, 4, 5, 6, 7. That means I would have 7 pairs of x's that cancel. 1, 2, 3, 4, 5, 6, 7. And once everything canceled, I only have 2 x's left in the denominator, which is what my answer right here was. Okay, so there's a couple of different ways you can look at that problem. You can simply solve it like it is, which means to add the exponents and get a -2, and then to make that a +2, you drop it into the denominator. Or you can actually write this out, simplify this first, make it a +9, which means you're going to drop it in the denominator. This one stays up where it is because that's a positive. You can subtract those, get a -2, or you can just write it out like this, see what cancels, and figure out what you have left. I know that one's a little bit confusing, but we're going to have more like that. All right, so on the next section, letter A, kind of the same thing. It says use the rule for negative exponents to simplify each expression so that it contains only positive exponents. So this is a multiplication problem. So I'm going to take these apart. To make that 5 positive, I'm going to drop this whole thing down in the denominator. So I have 2 to the 5th. I'm going to keep these separate so I can make it look like a multiplication problem, and I don't want y'all to go, well, I don't know why we're dividing like I did right here. I don't know why we're dividing when it says to multiply. So let me show you the first step, which I skipped on this one. All right, so I took the first number and I simplified it so it has a positive exponent by dropping the 2 down to the denominator and dropping my negative sign. Now I'm going to multiply it by the second number, which 2 to the 8th, and I keep it in the numerator because it's positive. I want it to stay positive. When I multiply straight across, 1 times 2 to the 8th is 2 to the 8th. And 2 to the 5th times 1 is 2 to the 5th. So now that's why it looks like a division problem. In my prior problem, I went straight from here to here, and I kind of skipped that first step of making it look like a multiplication problem. So anyway, I'm continuing on with the letter A. So now I have 8 2's in the top. I have 5 2's on the bottom. If I wrote all of those out, I would be able to cancel 5 pairs, and I would still have 3 2's left in the numerator, correct? Or the directions say if you have 2 numbers and you're finding the quotient, their quotient, and you subtract the 2 exponents. So 8 minus 5 is positive 3. So 2 to the 8th divided by 2 to the 5th is equal to 2 to the 3rd. Well, that's not a variable, so my calculator will do that problem. And 2 to the 3rd power is 8. Now, the neat thing about this calculator and this math problem is that you can literally do this whole entire math problem in your calculator. So let's do that. Let's say 2 raised to the negative 5th. Negative 5th. Make sure you right arrow, so right click so you can get down to the regular section, not just up here in the exponent. I'm going to multiply that by 2 to the 8th, 2 to the 8th. I'm going to right click and hit enter, and my answer is 8. So even without doing any of those steps, I use my calculator, type it in, and it goes straight to the final answer. All right, letter B. This is a positive exponent, so I can keep it down up here. This one is x to the negative first. Well, the only way to make that a positive 1 is I flip it over the line, so I'm actually going to bring it up here with my x to the 6th. My x to the 6th stays in the numerator. I'm going to move this up next to x to the 6th. And now it's a multiplication problem. X to the 6th times x to the 1st. The directions say to add my exponents, and I get x to the 7th. Since that's a variable, I have to stop. There's nothing else I can do. Now letter C, basically, if you have 2 negative exponents, you're going to flip these upside down because my 2 is going to come to the top and become positive. My 10 to the negative 5th is going to flip down to the bottom. I'm going to drop my negative sign. So I'm going to rewrite this before I solve it, 10 to the 2nd over 10 to the 5th. When I flip both of these over the line, my negative sign goes away. So now this looks like a quotient or a division problem. So basically I would have 10 times 10 divided by 10 to the 5th. Well, wouldn't these two go away? Wouldn't these two go away? So I'm going to have 3 sets of 10 in the bottom. So I have nothing left on the top, so I have to put a 1 there. 10 to the 3rd on the bottom. So when you have a division problem, you find the difference in your exponents. The difference of 2 and 5 is 3. And then you look at your problem and say, okay, do I have more 10s in the denominator or more 10s in the numerator? Well, if you have more 10s in the denominator, that means when everything cancels, that's where they have to stay. Since you have more in the denominator, your final answer has 10s left in the denominator. Now 10 to the 3rd power is 1,000. So my final answer on this one is 1 over 1,000. Like I said earlier, if you use your calculator and you type this original problem into your calculator, It'll go straight from this problem. It'll give you the final answer, 1/1000. But it's important that you practice using these rules just so you feel more comfortable with them. But just so you know, it's great to have that calculator. All right, letter D. Now, just like we can simplify on top and bottom with numbers like 2 and 8, or 3 and 12, or 10 and 15, well, we can do that with our exponents as well. We can simplify on top and bottom. So the first thing we're going to look at is letter D. So letter D, we're going to look at just our x's for a minute. Ignore those y's. So if you can imagine, you have 6 x's on top and 2 on the bottom. So you're going to cancel out 2 pairs of 6's. So 6 minus 2 is 4. So you have 4 x's left. Is it going to be on top or bottom? Well, do you have more x's on top or more x's on bottom? Since you have more x's on top, when you find the difference of 6 and 2, x to the 4th stays on top. 6 minus 2 is positive 4. All right, now look at the y's. This is like saying we have 3 y's on the top. Let's go ahead and write that out. And this is saying we have 5 y's on the bottom, 5 y's on the bottom. Well, when we cancel on top and bottom, aren't we going to have y's left over in the denominator? Isn't 3 subtract 5 negative 2? Well, if you wrote y to the negative second in the numerator, you'd have to drop it down. Or just think of it this way. Well, the difference in 5 and 3 is 2. And since I have more y's in the denominator in my problem, I'm going to have some extra y's in my denominator when I'm finished. All right, let's look at letter E. Now, this is a little tricky because you want to almost immediately say, okay, I can divide 15 and 3. However, if you want to divide these together, if you want to divide 15 by 3, you would also have to be able to divide 2 by 3. And since you can't simplify these two, since these two also don't simplify. But what you could do is go ahead, since these are on the top, they're coefficients and it's being multiplied, you can go ahead and multiply 15 times 2. 15 times 2 is 30. We're ignoring the denominator for a second. Well, the rule says if they have the same base, you add those exponents. So x to the 10th multiplied by x to the 2nd, you add the exponents and you get x to the 12th. And then our bottom, we're going to just write out what we have right now. All right, so now let's look at just our coefficients. Ignore the variables. 30 divided by 3 is 10. If that was a fraction, wouldn't the answer just be 10 or 10 over 1? Well, that's our answer. 30 divided by 3 is 10. Now, look at their x's, though. I have 12 x's on top, 15 on the bottom. So since it's a quotient, I'm going to subtract those two numbers. The difference in 12 and 15 is 3. But where do I put that x? Well, I have more x's on the bottom in my problem, which means my x's, those 3 extra x's, have to stay in the denominator. If it helps you to draw out 12 x's on top, 15 x's on bottom, cancel out all the pairs, you'll notice that you still have 3 x's left in the denominator. If you subtracted those, you would get negative 3. So you would have to write this problem 10 times x to the negative 3rd. Well, then you know the rule. For a negative exponent, you got to drop it to the denominator, and that exponent becomes positive. Cross the line, change the sign. All right, we have a special note. It says special note about using the quotient rule. Regardless of the size of the exponents or whether they are positive or negative, the following single subtraction rule can be used with the quotient rule. Numerator exponent minus the denominator exponent. This subtraction will always lead to the correct answer. So that's how we did this one when we simply said 12 minus 15 is negative 3. But since we got a negative 3, we had to drop that x to the bottom. All right, so this is sort of like the first page of your notes that you have. This is just a different way of writing it. So far, we've talked about the exponent of 1. If you don't see an exponent, it automatically is a 1. We've talked about any number or variable raised to the 0 power is equal to 1. We've talked about the product rule. If you have two numbers with the same base, you would add their exponents. The quotient rules, same base, you would subtract the exponents. And negative exponent simply means you're going to flip wherever that variable or number is raised to that negative exponent. You're going to flip it down to the either down, or if it's in the denominator, you flip it up.